Hello guys, Mr. Samuel Thomas here. Today I decided that we should discuss again this problem of determining whether a number is prime or not. But today we are going to use a different approach because I want to show you that there are so many roads that you can pass to get to a final solution. So don't just sit upon one particular solution. Try many different alternatives. Okay, so let's see another alternative today. So we know that a prime number is defined as a positive integer greater than 1 that has exactly two divisors, 1 and itself. Okay, so in approaching this problem, let us look at a pseudocode. Okay, let us begin with a pseudocode. So we're going to say start. We are going to display enter a positive integer. We are going to display that to the computer. And then next we are going to save that integer into a variable, say n. Okay, so we are going to say start, that is int main. Then we are going to display enter a positive integer. Then of course we are going to allocate memory to store that integer, and then we are going to actually store it into that memory that we allocated. Next, we are going to check if the number is 1, of course that's not prime, so we are going to display not prime. If the number is 2, we know that 2 is where prime numbers begin. Prime numbers begin at 2, so we are also going to display that 2 is also prime. So we are going to say if the number is 1, you want to display it is not prime. Then else if the number is 2, you want to display it is prime. It is prime. Next, according to the pseudocode here, else if the number is greater than or equal, else if the number is greater than 2. So if the number is greater than 2 here, we are going to do something. Okay, but that is not my point for now. Let me just remove this here. I want you to see this else part. Else, that is, if the number is 1, you want to do this. You see, if the number is 2, you want to do this. If the number is greater than 2, we are going to do that later. But else, that is, the number is not 1 and the number is not 2 and the number is not greater than 2. That means the number is probably less than 0. You get my point? Because it is not equal to 1, it is not equal to 2, and it is not greater than 2. So it means the user must have entered either 0 or something less than 0. So in that case, in the else part, we're going to display enter a positive integer. Okay, so let's capture that. So we are going to have else if the number is greater than 2. We are going to deal with that in a short moment. But else the user must have entered something we don't want him to, so we are going to display enter a positive integer. All right, so what do we want to do here? What if the user enters a number that is greater than 2? So let's come back here and let us bring back our pseudocode now. You see, so what do we want to do? When the user enters a number that is greater than 2, first of all, we are going to initialize k, some variable. It can be k or any other variable, to have a value of 2. And then next, we are going to initialize a Boolean variable, maybe is prime, and then we are going to set it as true. So initially we are going to say is prime to have a value of true. And then we are going to say while our variable k has not exceeded n, we are going to do the following. So why are we saying while the variable k has not exceeded n? So here's the concept, okay? Here's the concept. A prime number is the one that is only divisible by 1 and itself. only divisible by 1 and itself. So here we have initialized the k to start at 2 up to when k is less than n. You see that? So what do we mean here? Here what we mean is that k will start at 2, and then we are going to slowly increment it until a point where it is just before n. You see? And if at any point when we check whether n is divisible by k and we find that it is actually divisible, then this is an indication that this number is not a prime number, because a prime number cannot be divided by any other factor apart from 1 and itself. So if it will be divisible by 2 or by any other factor between 2 and before itself, if any other factor around there can divide that number, already that number is no longer prime. So what are we going to do? We are going to now set our is prime variable to false. Whenever that case occurs, we are going to set our is prime variable to false, and at that point we are going to terminate the loop. We are going to terminate the loop, meaning that there is no more need to continue going on to check other factors. As long as you reach a point where you have discovered that there is already an existing factor in between there, apart from 1 and itself, that is able to divide n, no need to continue the loop. You can terminate the loop and display that the number is no longer prime. So that is what we want to do. That is what we want to do. So let us now implement this algorithm. So here we are going to say, you can see here k is 2. So here we're going to say k, so we're going to say some variable k should start at 2, and then we're going to have a Boolean variable say is prime. We're going to initialize it to true at first, okay, to true at first. So we're going to say while k is less than n, what do you want to do? You want to do the following. If the number n is actually divisible by k, then this number cannot be prime, because a prime number cannot be divisible by 2, and it cannot be divisible by other numbers in between. It should only be divisible by 1 and itself. So we are saying if it is divisible, then this number is no longer prime. So here we can say we can set our Boolean variable to false, you see, because we have discovered that this number is not prime, you see. And once we set it to false, we can terminate the loop, you see. Here, once you set the Boolean variable to false, you can do what? You can terminate the loop. So how do you terminate the loop in programming? How do you terminate a loop? A loop is terminated using a statement called break. So you write here break, you see, you write there break. Once we do that, of course, here you can put this one here, you see. Great. Now when the loop terminates, execution will continue outside the body of the loop, you see. Execution will continue outside the body of the loop. So outside of the body of the loop, what do we want to do? We are going to check, you see. Even in the pseudocode here, you can see kwamba the loop, you see, this is at step 14. This is where the loop terminates. This is where the body of the loop ends. So once the loop has terminated, execution will continue at line 15. So at line 15, what do you want to do? You want to check if your variable is still true, then the number is successfully prime. Otherwise, then the number was what? Was not prime. So you're going to display not prime. So that is what we want to do. We are going to say if our variable still has a value of true, then the number was still prime. The number was totally prime. So you're going to display that the number was prime. You see, the number was prime. But otherwise you could just do like this. You could just say not prime, okay, not prime. So but also let me remind you, instead of writing like this, you remember there is a shorthand operator which is called the ternary operator. It is a shortcut for if else. It is a shortcut for if else. So instead of writing like this, you can instead write like this. You can instead write like this. If is prime, if is prime, you want to display prime. You want to display prime. Else, you want to display not prime. You want to display not prime. So this is the if part, and this is the else part. Okay. So it means this will be your if part. If true, you're going to do this. Otherwise, you're going to do this. So this is the shortcut for if else statement. Okay, you can use this style also. It's just okay. Feel free to use any style as long as you know what you're doing. All right. Okay. So if you run that, you see enter a positive integer. Let's say 97. You see, yeah. All right, so I think it's because we didn't put brackets here, I think. Let me try to put brackets here. Okay. All right, so 97. Yeah, you can see that. Okay, you can try another number. Okay, so let's say you try 101. You see, it's prime. Yeah, you can try another number. Let's say you can try 3. You see, it's prime. Great. So guys, that's it. This is what we say. This is what you say. Many roads lead to Rome. Okay, many roads lead to Rome. So always seek to understand. Seek to understand. Once you understand, you can do anything. Even this program, you can play around with it anyhow you want. Okay, you can, as long as you have understood. Just try things. Okay, just try things. That's it.